You should have a better understanding of why blood flows, but let's take a closer look at how the blood looks when flowing through the vessels. Matter is classified into three categories: solid, gas, and fluid. Fluids are substances that flow and take on the shape of their container. We consider flow to be the continuous movement of fluid, and by our definition, blood is indeed a fluid. The flow of blood has already been discussed. Recall that it tells us how much fluid is passing a certain point and is measured as a volume per time. Another measurement that can be taken of moving fluid is its velocity. Velocity tells us how fast the fluid is flowing. Similar to speed, velocity tells us a distance traveled, like miles per hour or meters per second. But unlike speed, velocity also gives us the direction. Could be forward, backward, positive, or negative. There are multiple ways to describe the way blood is flowing through vessels. First, we'll begin with physiological descriptors that tell us how blood is flowing due to the type of vessel it is and other factors. Pulsatile flow shows us blood that is moving at variable velocities, typically an acceleration and then deceleration that matches the cardiac cycle. Because it is closely related to the cardiac cycle, pulsatile flow is typically seen in arteries. Phasic flow is influenced by inhaling and exhaling. We learned earlier that veins have more forward flow during different parts of respiration. This increase in forward flow can be seen by ultrasound and is typically seen in veins. Steady flow then is when the fluid is moving at a constant speed and there is really no change in velocity. Typically only seen in the setting of disease or in vessels that are not affected by respiration or the heart. It is most likely seen in veins, especially the portal vein, but it can also be seen in the setting of stenosis in arteries. Universal fluid flows can be seen in other places outside of the body, but are still helpful when describing blood circulating in the body. This chart shows the four types that we will discuss and how they're related. As we think of blood flowing through vessels or any fluid flowing through a tube, you need to know that fluid flows in layers. The image will depict multiple arrows representing the layers and their endpoints representing how fast the blood is flowing compared to other layers. Laminar flow is the most common type of flow in arteries. The layers of blood travel in an organized manner in which the layers are parallel to one another. It is smooth flowing like a calm river. There are two types of laminar flow, plug and parabolic. Plug flow is a subset of laminar flow, so it means that the streamlines are parallel, but it also means that they travel at the same speed. Plug flow can be seen in larger vessels like the ascending aorta and at the beginning of branches like the carotid arteries. Finding plug flow at the beginning of a vessel is very common, and it's because the blood has not had enough friction to slow down any of the layers. Plug flow will eventually turn into parabolic flow. Enough drag occurs at the outer layer to almost completely stop the flow. This layer has a special name called the boundary layer. The next layers towards the center of the vessel will be slowed down by friction, as the next layer towards the middle is also slowed down by friction until we get to the middle layer. The middle layer experiences the least amount of friction and therefore travels the fastest. This flow is named for the profile of the blood that creates a curved parabola. Turbulent flow is chaotic. The layers no longer exist, but rather intermix and travel at different speeds and directions. The swirling has multiple names, including eddy and vortex. Turbulent flow is most commonly seen after some sort of narrowing or change in the vessel, like at the carotid bulb. In blood flow, we call the narrowing a stenosis. Turbulent flow is commonly, but not always, seen with pathology. Much like the rapids in a river, turbulent flow also transfers some of its energy into other forms like sound and vibration. This sound can be heard and is called a bruit. Listen to these crowded sounds. On the patient's right, you will hear a whoosh. That is the bruit. On the right and the left, you can hear a slight thumping. That is the heart beating. The left side exhibits silent laminar flow. When you can feel a stenosis, the vibration that you can feel is called a thrill. This is commonly felt on dialysis patients at their port of entry. Reynolds number is a unitless and is calculated by multiplying the velocity of blood times 2 times the radius and the density of blood, all divided by the viscosity of blood. The Reynolds number can predict if flow will be laminar or turbulent. You do not need to know this equation, but rather know that when Reynolds number is calculated to be less than 1500, the flow will be laminar. Reynolds number is calculated over 2000, the flow will be turbulent. Flow that lands in between 1500 and 2000 is undetermined and can be described as disturbed flow, not really laminar and not really turbulent.